Okay, so now we move on to part two of object-oriented programming. And here we're talking about two different types of attributes. Object attributes, class attributes. What are attributes? Attributes are just another name for properties, which we've been talking about before. So properties, characteristics, attributes, same deal. Now, all objects contain properties or attributes. Classes, which are different from objects, they are the blueprints for creating objects. They can also have attributes. And you will see when we go into the programming part that class attributes are different from object attributes. Class attributes are defined like variables within a class. Object attributes are tied to the object and they will generally be accessed by the name of the object, say, a dot initial rate, for instance. So this is an object attribute. It's an attribute of a, and you can set it to whatever value, for instance, say 100. Whereas within a class, you can specify an attribute, say sign of a well, like I show here. I'm going to get to that in a minute. You can just say sign equals 1. So you see this is like your regular variable which we've been talking about before. It will exist within the class and it's a property for the class. So any object you create from that class will automatically have this variable in it and they will all assume the same value. So it's applied class wide. If you have 1000 wells created from a producer well class, and in that producer well class, you have a class variable called sign, and you set it to 1. All 1000 of them will have a sign of +1, indicating the well, actually -1, indicating it's a producer. +1 will be indicating it's an injector. That's just any convention we choose, but basically, variables defined within a class directly, like this, are class attributes. They are properties of the class. That value will be applied to all the objects that are created from that class. Whereas, as you will see in the code later, when you have to always supply the object's name, a dot, then the name of the variable, in general, these are your object attributes. So that's the main difference between object attributes and class attributes. Object attributes are unique to the object. Class attributes apply to all objects created from that class. How do you create or how do you initialize object attributes? There is a function called the init function. It starts with double underscore, so 2 underscores. You type init, then prepend, after it, you append another 2 underscore and you open and close the parentheses, and you can supply arguments to that initializer function, and within that you'll do something like this. We'll walk through a practical example of this in code. So well ID, well name, cumulative production, initial flow rate, depth are examples of properties of a well object, because typically each well is going to have its own unique name. Each well will have its own unique ID. Each well will have its cumulative production, initial rate, and depth. They are all unique to each well object. Whereas again, for comparison, all producer wells can carry a sign of -1, indicating you're producing. So one value for all the different wells you initialize from a producer well class. The keyword to determine whether a variable is an object property is has a. So a well has a name, right? So name is a property. It has an ID, it's a property. It has cumulative production. It's a property, and this works for any type of properties, whether it's object property or class property. So producer well has a sign -1. So the has a is used to distinguish between properties and methods, which are the behaviors which we have talked about before. So while object attributes are specific to each object, class attributes are the same for all instances that you create from the class, like I explained earlier. So now we move to methods. Methods for an object. And we already said an object is an instance from a class, right? So these two mean the same thing. Instance methods, object methods, same deal. And essentially, they are like functions, which you already know how to define. They are like functions, but are tied to objects. So you know how to define the function. If you wanted to define a multiply function, we'll type in def, then multiply, and we'll provide whatever arguments we want and a colon, right? Then you indent and you start to do your stuff. Like you can initialize A to whatever, B to whatever. And next you can say C equals A times B, and you can return that, right? That's the function. It's just by itself in a code. For object methods, you're going to have a function defined within a class. And when you create an object from that class, the method, which is like the function, is already tied into the object. So if we create a well A object and it has a compute function, a compute rate function, you will have to call it this way, compute rate. Then you can provide the argument. So that function, compute rate, is defined within the well object. So it's like your regular function, but it has one main distinct functionality, and you're going to see a distinct difference, which you will see when we write the Python code. The first argument is always self. That's the main difference. And that self basically says it's a proxy for the current object you're dealing with, because we can create 1,000 different well objects, right? So each one will be referred to using self, and we'll talk about that when we get into the Python programming part. So instance methods, which are the same thing as object methods, are defined within a class, and you could use it to get and set the contents of that particular class instance. And a class instance, same as instance of a class, is an object, right? So you can set and get the contents of an object using instance methods. You can also compute different properties like rate, cumulative production, any actions the well can take or that can be taken on the well, you can provide it through instance methods. Those describe the behaviors. So they can be used to perform operations with the attributes of our objects. So the attributes are the properties of our object. So for instance, if you want to compute production rate for well A, and you already stored in well A its initial flow rate, initial decline rate, B exponents, which are the properties of well A, you wouldn't need to provide those as additional arguments to the compute rate function because they're already sitting in the object. So you will access them with something like well A.qi, well A.b for the B exponent, and perform the calculations here, and you wouldn't need to provide those as extra arguments. Those are the attributes of our objects. We are performing calculations in object methods using attributes that are already stored within the object. So methods provide the behaviors or actions of an object or that can be performed on an object. Like the init method, the first argument is always self. all methods in a class, which will end up being available in the object you create from that class, always has its first argument. When you define the method, the first argument will always be self. So that's the main difference between a regular function and a method. So a method is like a function, except that it has a first argument, which is self. And that first argument is what makes it a method and not just an ordinary function. Methods that set object properties, sometimes referred to as setters, because you use them to set the attributes of the object, while methods that get object properties are also referred to as getters or accessors, because that's what you use to access the properties, the characteristics, attributes stored within those objects. And the idea why we do that is so that we can restrict write access to each object's properties. In other programming languages, you have like private variables, and that means the only function, the only object that can modify those attributes is the current object. And that means you can't accidentally modify the content of an object from a random function or from some other part of the code. You will have to go through the object's setter to modify the content, which is what write access means, being able to write to the attributes of an object. So that's the main thing you do with setters and getters. You will modify the object's attributes with a setter. You will retrieve what is stored in the object using a getter. And this is the main idea behind data encapsulation. Encapsulation is one of the three main concepts in object-oriented programming. Data encapsulation, data hiding, that's another word for that. Information hiding. It's like you are hiding the information within the object, and you don't want any other object to be able to modify that. You need to go through that object to access the information in there with the getters and to modify or set the properties in there using the setter. It makes large computer programs easily maintainable. If every function can access every property, then everything gets very messy. You can accidentally modify the values within an object and have unintended consequences, and going through the code to look for exactly what is responsible for the error could make things extremely difficult. So that's why we do data encapsulation or information hiding, to allow us write codes that can be easily maintained, especially in a large enterprise when you're working with several other developers. You don't want to accidentally make modifications to code when you don't want to. So we use the concept of data encapsulation. Like I said, there are three main concepts in object-oriented programming. Data encapsulation is one. Another is inheritance, which we'll talk about next. And the third is polymorphism. All of this do not make any sense to you now, but they will shortly. So inheritance is the next one. And anytime inheritance is involved, there is always a parent and there is a child. So the concept is very straightforward. It's the process by which a class takes on attributes and methods from another class. Again, it's always about properties and actions, attributes, methods. So a class, this class can inherit the properties of this class. So this is the parent. This is one child class. You can have multiple child classes, right? all of them inheriting from the same parents. So this could be, okay, playing this here. This could be well class, any type of well. Then this could be a producer well, right? A production well is a producer. An injection well is an injector. An exploration well, a well we drill just to find out if oil is there. So all of these are wells, right? So they inherit from the generic, from the parent class well. So this is a sketch of how you could use the concept of inheritance. And it means everything you define within well is available in all of these. Then on top of that, you can modify any of the properties or methods that were already defined in well. So it allows you to customize well to provide unique functionality for producers. Same deal for injectors and for exploration wells. And that's one of the ways you can use the concept of inheritance in code. These are the producer, injector, and exploration are the child classes, whereas well is the parent class. Another name for parent class is superclass or base class. Another name for the child class is subclass or derived class. That's another name for child class. So child classes, like I explained, override or extend the functionality of the parent class. How do you extend functionality? By modifying attributes and behaviors, properties and methods. By default, the child class will inherit everything in the parent class, meaning the attributes and the behaviors, but can also specify new behaviors. So if you had specified only compute rate in the well parent class, you can put new functionalities, new methods in the producer, new methods like compute injection rate that is unique to the injector. For the producer, you can provide compute production rate, and maybe you don't provide that in the well. So you can add functionality, you can add more attributes, more properties to these child classes. In Python, the most basic class is the object class. So there is actually an objects class in Python. If you don't specify any parent class when you create your classes, by default it uses the object class as its parent. But if you specify, then it uses what you specify. That's one unique behavior of Python. Now we move on to polymorphism. So we've talked about data encapsulation or information hiding, which is an important concept in object-oriented programming. It basically means you hide information within objects, and to access those information, you need to go through the object's getters or setters. Then we talked about inheritance, which basically allows you to create a parent class and create subclasses from that parent class. And you can continue to extend that, right? There can be multiple levels of inheritance. So you can create another example, you can create a shape object. So the class, a shape class. The class is shape. Then you can create two child classes from that shape class. Let me illustrate that. So we have a shape class. Then you can create, just example, 2D shape, 3D shape, three-dimensional shape as children from the shape class. Then you can continue and create multiple different types of shapes from these, right? You can create triangles, rectangles, square, and on. So this is another level of inheritance. So triangle inherits 2D shape, which inherits shape, which probably inherits object, right? If you don't provide any superclass for that. And you can do the same thing for 3D shapes, pyramids, or a dome, which I talked about before, a cuboid, a cube, and on and on. So you can have multiple layers of inheritance. And now we move on to polymorphism, which is probably the most complex of the three, but very simple. Poly, multiple, right? Many. Morphism is forms. So it's multiple forms. That's the literal meaning. So it's being able to use the same interface for different forms, such as data types or classes. So we will, using polymorphism, we can use the same interface to access different types of objects. If this is not making much sense, I'll try to explain it a little further here, but it's going to be very clear when we look at examples in Python. So it allows objects belonging to one class to be used in the same way as if it were belonging to a different class. So if we revisit the example I had shown earlier, which is well class. For simplicity, let's just do producer well and injector, right? Injection well. So we already know a producer is a well. An injection well is a well. It inherits from, they both inherit from the parent class well. Now, these are classes, right? So we could create multiple producer wells, multiple injection wells, and we can actually create multiple wells which we haven't defined, whether it's a producer or injector, or it could be an exploration well. But each of them could have, say, well ID, right? Those are, or that is an attribute. So if you had a code that's looping through wells, so you're saying for each well, for well in, and you have a data type, maybe a list of multiple wells. Some of these wells could be ordinary wells, like from the parent class, or meaning objects, well objects created from the well parent class. Some could be well objects created from the producer class. Some could be from the injection class, and so on. So a well could be a parent well, it could be a producer, it could be an injector, it could be an injector, and on and on. And within this loop, you can say well. So first time through is going to be well 1, second time through is producer 1, next time through is injection 2, and so on. And you can do well dot well ID. So it's going to work regardless of the specific class these guys belong to. Same deal if you had a compute rate function which is overriding. So there's a compute rate function in well, there is a different one in producer, there's a different one in injector. The one in the producer uses, say, exponential model. The one in injector just multiplies time by the constant flow rate, Q times time. So different equations are implemented in all three different classes. And because there is a method called compute rate in all three different classes, at runtime when this code is running, it will automatically choose the right method to use depending on what object well 1, producer 1, injector 2 is. So for well 1, it's going to use the compute rate defined here. For producer 1, it's going to use the compute rate defined in this class. For injection well 2, it's going to use the compute rate defined in injector. That's basically polymorphism. So we are using this function in a polymorphic way in different forms. The code can tell at runtime which one it should use. And you will see an example for that when we look at the Python code. So polymorphism allows for flexibility and loose coupling so that you can easily extend code and maintain it over time. So if you need to add new functionality, you can, and your code is robust in the sense that it's not tied to the different types of the different objects. It's used when you have commonly named methods across classes and subclasses. So you can continue to use the method, and it's up to Python to figure out which classes the method is defined to choose the appropriate function to use. And this allows functions to use objects of any of these polymorphic classes without needing to be aware of the different distinctions across the classes. Most of these have been explained already. Polymorphism can be carried out through inheritance, like I showed in the previous slide, with subclasses making use of base class methods or overriding them when necessary. You override them by specifying a method of the same name in the child class, but you now provide a different functionality, a different equation, for instance. When several classes or subclasses have the same method names but different implementations for the same methods, those classes are polymorphic. They use the same interface, same method with different types, different classes. A function will be able to evaluate these polymorphic methods without knowing which classes are invoked. So it's able to do it at runtime. And in summary, again, these are the 3 core object-oriented programming concepts usually tested during job interviews, internship interviews: data encapsulation or information hiding, hiding functionality within objects, and using accessors, meaning getters and setters, to modify the properties of the object only from one place through the object, not from anywhere in the code, which could make code messy. Inheritance, which we just talked about. You have a parent class and you can customize the functionality in that parent class by providing the same variable name, same method, same attribute within the child class. In polymorphism, multiple forms using an interface, the same interface name, and you're providing, and it's doing different calculations depending on what the object is.